We can also use the same kind of techniques to answer a question like this one. So the same 444 grams we were dealing with in the last video, but now we want to know how many of those grams, how many oxygen atoms there are in those 444 grams. So you are already familiar with the idea of conversion factors, and you're already familiar with things like every chair shaped like this has 4 legs. So if you knew a room contained 10 chairs, every chair has 4 legs, that's a total of 40 chair legs. The same thing is true from the subscripts in the balanced chemical formula. This represents a molecule of water, and there are 2 hydrogen atoms for every molecule of water. So if you can count the number of molecules, you can use this as a conversion factor. We're going to do the same sort of thing with the dinitrogen trioxide. We want to know how many oxygen atoms are in 444 grams of N2O3. So this is just like the previous problem. We're going to start by converting our grams into moles using the molar mass, which we get from the periodic table. Every mole of N2O3 weighs 76.02 grams. And if we can count how many molecules, which we can, because we know that a mole of anything is Avogadro's number. So I'm running out of space, but this would be molecules of N2O3. So this is just like the previous problem we worked. Now we're going to take it one step further. One molecule of N2O3. The subscript 3 tells us that every molecule contains 3 oxygen atoms. So we get an answer of 1.06 times 10 to the 25th oxygen atoms. We could also break that down by mass. If we wanted to know how many grams of nitrogen, how many grams of oxygen. So our unknown again, let's do how many grams of nitrogen are there in 444 grams of N2O3. Our first step, use the molar mass. (76.02 grams, 1 mole of N2O3. And this time we're going to do it a little bit differently. There's different ways that you can come up with the same answer. The 2 to 3 ratio is the ratio between nitrogen atoms and oxygen atoms. That's always going to be the case. If we had a dozen of these, there would be 2 dozen nitrogens and 3 dozen oxygens. So I'm going to stick with the unit of moles, and if I had 1 mole of N2O3, I know I have 2 moles of nitrogen because of that subscript 2. And then once I have moles of nitrogen, I can go to the periodic table, which will give me the mass of every mole, 14.01 grams. So my total is 163.65 grams of nitrogen. I could have gone to molecules and then counted how many molecules I had, and then counted how many atoms of nitrogen I had, but I would do a little more work that way. I'd have to use Avogadro's number a couple of times to do that, but you could come up with the same answer. So you could try this for oxygen the same way. Now we know the total has to be 444 grams. So if you set up a problem like this, the conversion here would be different. Instead of a 1 to 2 ratio, it would be a 1 to 3 because the oxygen subscript is a 3. And nitrogen and oxygen do not weigh the same. So when you try that, the total will be 280.35 grams of oxygen. And if you add those two numbers together, that'll give you the total of 444 because those are the only two elements that make up this compound.